what happened on the server, and produce an XES event log, the basis for process mining. We used PLG2 of Andrea Boratin to create the simulation and simulate the interaction with an HL7 fire server. And we used the PROM plugin Inductive Visual Miner from Sandar to, discover a process model based on the resulting XES file. Of course, the simulation was not the main focus of our study, so we used a kind of hacky approach to simulate a simple process in radiology. It's the basic radiology practice workflow comprising the scheduling of an appointment, patient admission, the examination, diagnosis, report writing, attestation, and transmission. And what we did, to explain how the whole thing works, I will go on with explaining how we simulated the report writing activity and how we reconstructed it afterwards. So for each of those activities, the simulator, the PLG2 simulator, needed to create, read or update or delete fire resources on the server. For example, to create the diagnostic report, you would have to, post a diagnostic report resource. The resource itself is a JSON object with a number of attributes referencing to the patient and to the encounter. And of course, it would have some content, but in our case, we didn't work with any content at all. We just created diagnostic report resources if we wanted to simulate the step of writing a report. So we didn't care at all for the clinical content in that case. The HL7 fire server was auditing all interactions with it. So whenever someone creates, reads, updates, or deletes resources on the HL7 fire server, it has to audit this interaction, say what happened, when did it happen, who initiated it, who was the, on what entities, on what objects was the manipulation happening, and in what context. So this auditing, of course, happens because of security reasons. And what we wanted to do was to use this audit information for process mining. In order to be able to do that, we extended the audit event resource, but I will talk about that a bit later. So in order to map the traces, so to identify the process instances, we considered the set of all resources on the fire server and took the subset of all audit event resources and grouped it by audit events, which were referring to a specific plan definition, which means they were created in course of the execution of a specific workflow, like the radiology workflow that I used in my example. And for all those, so the set AW was divided into subsets based on single encounters. So there were single encounters, which are encounters with patients, that were used for grouping the set of all audit events recorded in the course of executing a radiology workflow to identify the single traces. For all the events in the traces, we used a simple mapping table saying, okay, for example, creating an appointment resource equals the activity of scheduling an appointment in this context. Or updating the appointment resource when the patient enters the procedure room, not the procedure room, but the radiology facility, equals the activity of patient admission, and so on. So the combination of the verb, the operation on the fire resource and the fire resource was mapped to a specific activity. Of course, within the context of a specific encounter and a specific plan definition. So not every creation of an appointment resource would result in a scheduled appointment activity in a radiology workflow. This wouldn't make sense. Based on the grouping in traces and the mapping of the single activities, we extended the HL7 fire server with a new operation called, well, $XES, which is the nomenclature for operations, which means that you query for audit event resources, but you want to execute an operation on the result set before you return it. And the operation you execute on this result set, so the set of all audit events which were recorded in the course of a specific plan definition, the radiology workflow. You want to group those by the traces and return an XES event log. I just produced a small example in here because, well, the whole event log would be a bit too large, but you can see the one event that I was describing before, the report writing, was successfully mapped from the audit event that we saw before for the report writing into an XES event using the semantic extensions for concept and time to describe what happened. Of course, from there on, it's quite easy. Having an XES event log makes it possible to discover, or in our case, to rediscover the process model that we used initially for simulation. So the result, as expected, equals the input model. Well, so to the discussion, the PLG2 extensions were quite techy, but for our use case, sufficient. We used the Python script that Andrea Boratin intended for scripting the timing properties of a PPMN model. And we injected curl statements to just, well, create, read, update, and delete HL7 fire resources. This is, of course, not what Andrea Boratin intended when he wrote his simulator, but it worked anyway. In order to have a better kind of simulation of models and interacting with HL7 fire servers, properly creating, reading, updating, and deleting resources on an HL7 file server, this should be, of course, less hacky and better documented. So that's definitely future work. On the other side, we had to extend the audit event resource to add references to plan definition and encounter, the two attributes that we used for grouping of traces and identifying of, well, process instances. We didn't do that in a vacuum. We spoke with the standards developing organization, HL7, and we contributed to the workflow management group there. There is already an active change request for the next iteration of the HL7 FHIR standard, which will be release 5, to include those new references to plan definition and encounter. And this would, provided that the HL7 FHIR servers log correctly, instantly enable process mining on healthcare information systems once you, well, get the mapping right. Which brings us to the last point. Considering different perspectives on those data, we had some kind of hardwired mapping. We always said, okay, we want to have process instances based on patient encounters. As you all know, this is not the only perspective you could take on healthcare data, and there are lots of different possibilities and perspectives that you should take into account analyzing healthcare data. In order to enable this, we should utilize the FHIR query parameters to set the perspective. This is future work, and we are currently working on this to enable the setting of the perspective via the query of the XES file. Well, that's it from my side. I think I was also in my time slot, hopefully.
Your timing was perfect, Emmanuel.
Perfect. So are there any questions?
Yep. Thank you for this also important technical contribution. So are there questions for Emmanuel? So you can raise your hand. Yeah, Owen is already waving. Please go ahead, Owen.
I think Marcos and Carlos beat me to it actually, but okay. So I think this is really exciting. It addresses, I think, some of the data quality issues that we talk about too often in these sessions, because this is getting the data straight from source. It also potentially opens up the possibility of a real-time process mining, because the FHIR feeds are live. And if you can feed them into process mining tools live, then that is really exciting. So the bit, Emmanuel, that you didn't do, and I just wonder what your reasoning was you use simulated data, synthetic data, rather than taking lots of real data. So why did you go that route, and when can you start using the real stuff?
Well, the reasons in that case twofold. One is there are no HL7 FHIR servers who that currently implemented audit events with the extensions needed for process mining, of course. So we would have needed to convince some healthcare information system provider to implement our extensions into their live system to get real data, which was not realistic in our case. So we said we will take the other way around, simulate it and prove that it's possible. So that's a proof of concept. Then convince the standardization organization to implement it in the standard. And well, then there will be real data using these kinds of extensions for process mining. So yes, it's true. We didn't do it on real data. We took the other way around.
So can I just quick come back? Is I understand obviously they're not there with HL7 FHIR yet, but one of the possibilities would be to take some historic data in one of the older formats and then run your own conversion from that into FHIR so that you could then test it. It'd just be, I think you might have a very long wait before you get real HL7 FHIR coming out of real EPRs that then are kind enough to let you use it. But,
yeah, you're right. The other or another possibility would be to use audit event logs based on older IHE based systems, so which implement some kind of audit record repository based on HL7 version 3 messages or something like that.
Yeah.
But we didn't take that into account in our study.
Okay, good. Okay.
Thank you.
Other questions for Emmanuel? We still have time for one last question.
Carlos, I think.
Yeah,
hi, Emmanuel. So very nice presentation. I have a question because I'm working in a project that is we're working with FHIR, and we are accessing to a very, very large database for more than 10 million of patients. A lot of data for the community of Madrid, all the community. So we have a lot of data, and our main problem on that is to the performance, because when you are looking making a lot of calls with REST, the specific things, the idea to create a view with all data in order to create a database, a log, in fact, a log to be used in process mining. So you are working with that problem. We have the same problems on that, or you are a big database or not? What do you feel to get this view?
Mm-hmm. So it would be interesting to not only run it on 10 process instances, but maybe on 10,000 or 10 millions. We didn't do that. So we didn't do any kind of performance analysis. I think it depends on the performance and the efficiency of the query operator and query, well, implemented on your HL7 FHIR server. So how efficient, how performant is your database, and how fast can it execute queries? Well, that's another course of research, of course, but not the focus in this study. I think that's a problem in all kind of systems. Once the data grows too large, you will have to come up with new ideas to query it in a timely manner. So did you encounter any specific problems because of HL7 FHIR, or is it more like a general big data problem?
No, the problem in that is because in FHIR, we have all the HL7 ontology in front of that, and in order to get specific things in a specific point, you should ask for specific things to create the view. So this is the main problem on that, because you are a log with all the data that you need in a search file. This is not a problem. You can make the process mining very quick because you go trace by trace. But if you are working in a database like FHIR in general, you should get specific views. In fact, we are looking for an intermediate database that have the data in a specific format that can feed the tool or something. Because we have this very big problem, because probably to get all the data that we need, it takes 3 days from the server. This is the main problem, because to create a process mining tool that very quick online process mining with FHIR, we have some problems.
Mm-hmm.
We're also with people of OpenEHR community that are creating some tools that we can try to get that, but the problem is the query and how to get the data and how to process that.
This is, I think, a very interesting point, more for the medical informatics community, because the performance of HL7 FHIR databases is a very interesting point once you go to analysis. The standard does not define how you build your database. The standard only defines the interface to the database. So how you structure your data behind the interface is completely up to you. And if you have performance problems, well, you could maybe try graph databases or something like that to structure the relationships between the resources as well.
Okay, thank you. Maybe just round up this discussion indeed here. I think it's definitely to be continued in one of the coming hours or days. So thank you, Emmanuel, for your presentation. And now we're going to proceed to the final presentation within this session. And that's a presentation by Yoon-Gyun Lim and co-authors, entitled Deriving a Sophisticated Clinical Pathway Based on Patient Conditions from Electronic Health Record Data. So Yoon-Gyun, you can share your screen.
Okay.
Yeah, we can see your screen and you can immediately start with your presentation.
Okay. So can you see it?
Yes, we can see it and we can hear you perfectly. So please go ahead.
Good afternoon. This is Jung-eun Lim from POSTECH, South Korea. Today, I'm going to present our research work driving a sophisticated clinical pathway based on patient conditions from EHR data. This presentation will be preceded in this order. First, I'm going to introduce what is clinical pathway and what we try to do in this research. In the method part, I will explain a framework for deriving sophisticated CP considering medical KPIs. The proposed method is used in a case study. I will explain the case study results, and finally, I will conclude our work. The clinical pathway, which is usually called CP, is a standardized care process for specific disease or surgery. The previous works proved that if we have standardized process, the quality of medical services is improved. For example, complication rates and mortality decreases using CP. At the same time, the cost, like a length of stays and medical expenses, also decreases. Because of this advantage, many hospitals are trying to use CP. CP consists of several orders. Order is one of the clinical events and contains information such as drugs, tests, and some activities that patients should do. The table shows an example of CP. Unlike a conventional process model such as PetriNet or BPMN that shows the relationship between activities, the CP does not show the activities causality. However, it defines the set of activities that should be conducted for each day. In the table, the CP is for 4 days, and drug order shows drug uses information, and lab test shows which test should be taken that day. So there are some researches for CP, but there is a gap between the focus in the previous works and requirements from the medical domain. Most researches focus on the effective algorithm. They try to find algorithms for CP discovery from events log and analyze CP variants and CP patterns using various techniques. However, in the medical field, practitioners want to have not only just analysis result, but also some insights that can be used for CP development. Explaining the analysis results is essential for practical use, and reflecting domain knowledge or expert domain is needed. Furthermore, considering and improving medical KPI is necessary. Thus, in this research, we develop a framework that helps practitioners develop CP from events log by considering medical KPIs. This is an overview of the proposed framework. The framework consists of 4 steps. They are data preparation and feature engineering and statistical analysis, and last post hoc analysis and CP development. I will explain each step in detail. The first step is data preparation. There are several healthcare information systems such as EMR, CPOE, LIS, and PMS. Relevant information is distributed to them, so data from such systems should be integrated. After that, the preprocessing of missing data, incorrect data, and so on is conducted. The preprocessed data consists of case attributes, clinical events, and clinical event attributes. Case attributes are information about a patient, such as age, sex, allergy, and disease history. Clinical events are events that belong to a case, and admission, discharge, and diagnosis events are examples of case events. Clinical event could have attributes such as department, information, type of drug, and so on. The case attributes and some derived variables from clinical events and event attributes are used in step 2, and clinical events are used for CP development in step 4. The second step is feature engineering. In this step, we derive patient characteristic variables and medical KPIs by selecting or processing the data collected in step 1. Patient characteristic variables are used for CP segmentation. For each variable, considering medical KPIs, further analysis is performed in step 3 to check whether a CP segmentation is needed or not. Note that there are a handful of variables and KPIs possible. Among them, some important ones should be selected by the discussion with medical experts. For patient characteristics, we derive 10 variables from case attributes and 5 variables from clinical events. Case attributes include demographic information such as age, category, and sex, disease history such as allergy and chronic disease, and administrative elements like severity and admission type. Clinical event variables show the frequency of some events, such as the number of diagnoses from other departments, the number of ward transfers, and so on. As KPIs, we use length of stays, medical costs, and the number of antibiotics and CP order matching rates. The first 3 variables are commonly used in hospitals, and the last one, CP order matching rates, is the indicator we proposed to use to show a patient's conformance to the existing CP. This slide shows how to calculate CP order matching rates. It is as same as the fitness value in conformance checking in process mining. It counts confirming, missing, and additional activities between the existing CP and the event log that a patient had. For example, in the figure, there are 12 orders in the existing CP, but only 8 orders are the same as orders in order trace. They are conforming activities and colored gray. There is also green one in the existing CP. They do not occur in the order trace. We can see that it is a missing activity. As a missing activity decreases, matching rates increases. In the order trace, there are orange circles. We can't find them in the existing CP. They are additional activities. As an additional activity decrease, matching rates increase. After defining the variables in step 2, distinctive patient characteristics should be identified in step 3. For that, hypothesis testing is performed based on dependent and independent variables derived in step 2. We use 2 methods for the test, the Mann-Whitney-U test and John-Curie-Terpstra test. When the patients are divided into 2 groups by a patient such as sex and severity, the Mann-Whitney-U test is used. The John-Curie-Terpstra test is applied when the number of groups is more than 2 and they are ordered. For example, when the patients are divided based on the number of transfer, we can have 3 groups. Because there are more than 2 groups and they are ordered, the JT test should be applied. In the last step, with the features that affects KPIs, post-hoc analysis and CP development is conducted. In the post-hoc analysis, considering the features, differences in orders between groups are investigated. First, the difference in the application rates of each order is calculated for each group. Second, to visualize the differences, we apply trace alignment. The visualization can highlight the differences in an effective way. With the application rates and the visualization results, we should have a discussion with medical experts. If they agree, a new CP can be developed for patients who have a specific characteristic. After finding some important features, we could develop a new clinical pathways considering the features. CP development is done using a matching rate-based algorithm. This algorithm is a greedy method to find the order set, which results in the highest average matching rate. After initializing a CP, in each iteration, the order with the highest application rate is added in the CP, and a matching rate is calculated. When we have the highest matching rate, we'll stop the iteration. In the graph, the blue line is a change in the rates of missing activities, and the orange line is a change in the rates of additional activities. When the number of orders in the set increases, missing rates also increases, and blue value become decrease. But additional activities decrease, and orange value increases. So the algorithm gives the order set, which makes the sum of blue and orange highest as a result. A case study was conducted using the proposed framework in SNUBH. SNUBH is one of the major hospitals in Korea. They have about 1,300 beds and more than 4,500 outpatients per day. In the case study, the TRH process was investigated. We extracted the data from January 2012 to April 2016. They are 1,100 inpatients and about 45,000 events. And there were about 300 drug orders and about 250 lab test orders. In the first step, pre-processing was performed, and we obtained 5 chronic diseases as case attributes. They are diabetes and hypertension, hyperlipidemia, cardiovascular disease, and cerebrovascular disease. In addition to these, severity is chosen as a case attribute. As clinical events, we consider 7 general activities and about 600 other activities. In the second step, we discussed with medical experts to select important variables, and 15 variables are chosen. Since the number of patients for each variable value should be more than 30, but some of them were under 30, so they are excluded. Finally, we had 6 as independent variables. They are severity, number of transfer of wards, number of diagnoses from the other departments, number of referrals to other departments, diabetes, and hypertension. With the discussion with medical experts, we choose 2 KPIs as dependent variables. They are ROS and CP order matching rates. The figure shows the distribution of ROS and the matching rate. As you can see in the figure, there are some extremes in both graphs. In step 3, the statistical analysis is conducted. Among the 6 independent variables, diabetes, severity, and referrals for other departments has statistical significance. They are the characteristics that should be considered for CP development. Among these 3, we have performed a further analysis with diabetes patients. In the visualization of trace alignment result, we could see that the diabetic patients got more orders than non-diabetic patients. The analysis results convinced the medical doctors to create new CPs for diabetic patients and improve existing CP for non-diabetic patients. So using a matching rate-based CP mining algorithm, we have made new CPs for diabetic patients and for non-diabetic patients. This slide shows the differences. For non-diabetic patients, 3 orders are excluded and 1 order is added. For diabetic patients, 3 orders are also excluded, but 8 orders are included in the new CP. They are orders to control glucose. The medical experts admitted that existing CP should be changed and a diabetic CP should be introduced as the algorithm suggested. This is the conclusion of this work. This paper proposes a framework to increase the applicability of CPs and suggests how to find CP variance using patient characteristics and medical KPI. To validate the proposed framework, a case study was conducted. The proposed framework is easy to follow and intuitive for healthcare professionals. However, there are some limitations. We just did 1 case study and we did not consider interrelationship between patient characteristics. As future works, we need more case study and we want to extend the proposed approach by considering interrelationship between characteristics. This is the end of my presentation and thank you for listening.
Thank you very much for your presentation of your nice work that you developed. So in the sense of timing, because the timing is very tight, there's time for 1 quick question, but what I would propose is that if there are further questions, just leave them in the chat and then we can discuss the paper there a bit further. But if there's 1 short question, we can take it now.
Hi, it's Owen. I just want to say that was very, very good. Thank you. It was very clear. So it wasn't really a question, it was just a bit of praise. What would be interesting, I think, would be to correlate successful outcomes and unsuccessful outcomes with deviations from the pathway. And that might be where you want to go next in thinking about the pathways. Now that you've got people down as diabetics, if they follow the pathway, do they get better outcomes than if they don't follow the pathway?
Yeah.
Okay.
Thank you.
That was a comment rather than a question, sorry.
It's for to work on the next weeks and months.
Exactly.
Okay, thank you. I'm going to close this session here then. So there's a very short break now and we will start with the 3rd session at 2:45. So in a bit more than 10 minutes. So grab a cup of coffee or a small snack so that you're full of energy again for the 3rd session, which will start in about 10 minutes. So see you later.